swatch bharath program Incois వాళ్ళు కండక్ట్ చేశారండి with Pragnya Montessori. This is the Incois inside. See, can you see the greenery inside? Green plants, beautiful flowers. It's very pleasant actually. They are giving some refreshments for the kids who participated in Swatch Bharat. They are serving watermelon juice too.
Everyday life. Because you are studying in Pragnya Montessori School, and then because I am in Hyderabad, there is no ocean. It's not that we should not worry about the ocean. What the ocean does in those coastal areas, it actually impacts how much rainfall we get in Hyderabad, or how much heat it can actually be in summer, or so it can impact everything that we do. Our entire everyday life is impacted in a big way by the oceans. So we have to study the oceans. That's what we do here. And how do we study the oceans? Like actually, you go to a doctor. If he wants to check the health of a patient, what does he do? He actually has a thermometer. He checks your body temperature. He has a sphygmomanometer. He checks your blood pressure. So there are certain instruments with which doctors, try to get some information on the health of the human system. Similarly, scientists working out here at Incois, we have certain tools with which we observe the oceans, because the oceans are very remote, they're very expansive. You can't go to each and every point in the ocean and make measurements. So we all have equipment. We use satellites. We have ground stations here, about 3. When you come next time, we'll show you some of those facilities if you're interested. We capture about 30 to 40 satellite passes every single day. And that satellite data gives us information on sea surface temperature, sea surface winds, ocean surface salinity. So salinity is the amount of water content in the seawater. Amount of salt content in the seawater. Seawater is salty. You all know that actually. So the amount of salinity, all these measurements are made. We can make those measurements through satellites. At the same time, we can also put instruments in the ocean. Somebody was asking what is an argo float, that yellow thing that you've seen. These are all robotic instruments. You can actually go and deploy them in the ocean. Once you deploy an argo float, it can go to a depth of 2 kilometers, 2000 meters below the water surface. Then it can actually rise. While rising, it can measure temperature and salinity of ocean water. It comes up, transmits the data to a satellite, which is received here on this campus. So this real-time information, we need to deploy about 3,000 such floats in the global oceans to know what is the temperature and salinity of the global ocean up to a certain depth. That information is very important for us to understand the ocean, model the ocean, and forecast the ocean. So that's one equipment. Then we also have equipments called gliders. These are like autonomous underwater vehicles. You can deploy them. You can actually command that the gliders to go from point A to point B, say from India to Indonesia or Port Blair. You can program them. They can come up, make measurements, transmit the data to a satellite. Then you can reprogram them again if you want, and then have several measurements. It's not just temperature, salinity. You can measure the light content in the ocean, because it's not just temperature, salinity. It's not just the physical constituents of ocean that we are interested in. We also need to know the biology of the oceans. How much of green, on the terrestrial system, you have trees which have chlorophyll and then which actually contribute to the primary productivity. In oceans also produce energy, food in the ocean, which is eaten by zooplankton. It is eaten by then fish, small fish, large fish. That's how the ocean biological ecosystem functions. So those measurements we can make, and all that is dependent on how much light is getting into the ocean and to what depth. Okay, so those measurements, those sensors can be put on these gliders. You can make the measurements of light. You can make the measurements of how much chlorophyll is available in the oceans and how much productivity could be there in the ocean. You also have heard about global warming, which is actually rising the sea levels. because of increase in heat, it is melting ice caps, it is expanding the volume of seawater, and then it is inundating our coastal areas. What used to be, like you ask your parents when you go with them to the beach, where was the beach when they were young? They'll certainly tell you it's not at the place where it is right now, where you're seeing today. It was either, somewhere far inside, or, the sea has encroached a large part of the land. All that happens because of this sea level rise. So we study that sea level rise, coastal erosion, all those impacts of the ocean on the coastal ecosystems, human ecosystems. So we make observations using a lot of instruments. We manage the data. A lot of your parents must be working in IT, right? So we actually also do a lot of IT here because we manage the data. We actually visualize the data. We use that data in ocean modeling. We have high performance computing systems that we use to actually simulate how that ocean functions, ocean performs, how the ocean currents. Okay, so all these things are simulated, and then so we do ocean modeling, and then we do forecasting, like you've seen in the video. We tell fishermen where they can go and do fishing so that their catches will be better. Or we can tell fishermen on where they should go or where they should not go, because the ocean conditions are very rough. It might be, dangerous for their navigation in the sea. So we do that. We tell, coastal people that they should evacuate. If there's a huge earthquake, if it can trigger a tsunami, you all know, you all probably you were not born, several of the younger kids. In 2004, a huge tsunami took around 230,000 lives, the worst ever recorded disaster in human history. 230,000 people died in 2004 because of tsunami. So now we can make forecasting of the tsunami. We can tell 2 hours in advance when a tsunami is coming your way if you're in the beach. So that we do. We do storm surge forecasting. So several things that are related to the common man. Now, what are you being taught in the school? You may become engineers, you become doctors, accountants, you become oceanographers. I'm sure I'm trying to tempt you to become oceanographers. That's what I'm doing. Okay. So whatever you do, you can become anything that you're interested in. You're studying in a wonderful school. And whatever you do, just remember that it should be useful for the society finally. You can do things that are useful for the common man, a person on the beach or on the road or anywhere actually, so it should be useful for the society. So that's what we do here. So with these few words, and I think you have something announcement to make. Please go ahead, and then when you're done, actually we'll take students in 2 or 3 batches to see a few of their facilities if they are not there. Thank you.
Now 2 of our students are interested to perform a dance. It's a classical dance. So I request Hamsini and Meenakshi to come on the stage.
and So this is Tsunami Early Warning Center where we monitoring about the tsunami activities. So actually here we work 24/7. So day and night we keep on monitoring the tsunami activities. So this center works day and night. So what we do here actually, have you heard about the earthquakes and tsunamis? Mainly you.
Yes, sir.
What you heard? Earthquakes or tsunamis?
Both.
Okay, good. So actually, tsunamis are generated mainly due to the earthquakes. So earthquakes are the prime cause to generate the tsunamis. So why this earthquakes occurs means, so our earth is divided into different plates. So if you observe this screen, there are different colors, plate boundaries are there. These are called tectonic plates. So example, wherever that lines are there, that is the boundaries of the plates. So what it do actually, these plates are moving each other. So example, say red color, yellow color and sand color. Red color is called convergent boundary. So means one plate is going beneath the other one, and yellow color means two plates are spreading each other, and sand color means two plates are moving each other. So these are the movements will be occurred due to the internal forces. So whenever that plate movements occurred, that cause the earthquake. So earthquake can be caused like, show the animation, Ravi. Can you show? Earthquake generation. नहीं उधर ना आगे ओपन करके So whenever suppose this is one plate, this is the other plate, as I explained there, na. So like this, if this type of two plates are there, so whenever one plate is going beneath the other one, so at certain depth, the energy will be released. So whenever that energy got released in the ocean, someone can come front slightly, can front. It's occurred like whenever this type of occurred in the ocean, that caused the snap. Can you play one more time? So as I mentioned, so this is one plate, this is another plate. This is called subducting. One plate is going beneath the other one. Whenever this type of movements are occurred at certain depths, energy will be released. That cause the earthquake. Whenever the earthquake caused in the ocean, that caused the tsunami. So once that movement is occurred, then Raki, inundation. So when that wave is coming to the coast, what happened? First one. So most of the time what happened? Water will go back. It is recede back. And it will come with high energy, with high intensity. So you see, so all like what will come and it will be flooded, entire area will be flooded. So like this actually tsunami, in real case tsunami occurred like that way. So that's why actually most of damage is along the coastal point. So then what we do here? So first as I mentioned, earthquakes are the prime cause to generate the tsunami. So we monitor where earthquakes are occurring. So to monitor the earthquakes, there are sensors called seismometers. Seismograph, you heard about in the 8th class, there is a lessons called about the seismograph related. And each triangle is indicating one seismic station. It's a seismograph station. And this magazine, yeah. Each triangle is these all are the land-based stations. So whenever actually it's records the ground displacement actually. So what happened? So this data is coming real time. Real time means every second data used to come. So it's not only India. So we are getting data all over the globe. We are getting more than 400 seismic stations data all over the globe. So whenever any earthquake occurred, so data is keep on coming regularly. Show that data. Waveform data. So data keep on coming every second. So whenever say this is the data, this is current time. So time is in GMT, Greenwich Period, UTC, Universal Time Coordinate GMT. It's a 5.5 hours. Means Indian Standard Time is 5.5 hours. Yeah. So because worldwide we are following same time, right? This is the current time in the GMT. And each place belongs to one station. So whenever any earthquake occurred, that automatically, if you observe every second data used to come. So whenever any changes comes due to the amplitude variations, due to the phase variations, then it is taking as an earthquake. So whenever this type of earthquake comes, example 2 hours, that is 34 minutes back, there is an earthquake in the Java. So this yellow circle is the epicenter of that earthquake. The earthquake occurred around 2.5 hours back. In the Java, earthquake magnitude was 5.2 and earthquake depth was 117 kilometers. So worldwide, any earthquake occurred that can be able to identify here within 5 to 6 minutes time. So within 5 to 6 minutes, we are able to, with earthquake prediction is not possible, but whenever any earthquake occurred, that can be predicted within 5 to 6 minutes, worldwide, any earthquake. So then our role will start, the earthquake is generating tsunami or not. So we means earthquake, whenever earthquake got detected, that is like a postmortem thing. We can't predict us. But after that, the particular earthquake is generating tsunami or not, we need to identify. For that purpose, so we have the tsunami, actually we have the star drafting process. That means that, example, tsunamis can be generated above 6.5 magnitude. That should be happened ocean or near coast. Suppose if any earthquake occurred in the land, what it won't generate the tsunamis. So example, say 6.5 magnitude occurred, say same location. Then we have the database of the all the coastal administrators like district level and state level and even national level. We have the all the database of their email IDs, mobile numbers and fax numbers. So whenever above 6.5 earthquake occurred, then automatically the information will be disseminated through email, SMS and fax. So it's automatically within 10 minutes. So whenever earthquake occurs, from the earthquake occurrence, within 10 minutes, all these administrators have the information where earthquake occurred, what is that magnitude. So that information will be available within 10 minutes. So because once tsunami got generated, we have only 2 to 3 hours time. So within 10 minutes, we can issue the bulletins that first bulletin will be informed that, okay, where earthquake occurred, that earthquake is chance to generate tsunami or not. So further, the particular earthquake is got generated, when that particular tsunami is going to generate and when it is reached to the coast. For that information, we have the, if we take the Indian Ocean, we have the 2 places tsunamis can be occurred. One is called Andaman, this Nicobar, Java, Sumatra, this region. One more is called Makran. Here it's like Iran, Pakistan, India. These 2 are the tsunami genic zones. If you observe there also, wherever red color is there, convergent boundary is the, it's a chances to generate earthquakes. So these 2 are. And 2004, I think you all are aware about it. 2004, 26 December, there was an earthquake of 9.2 was occurred in the Indonesia here, and that got generated a tsunami. Due to that, around 2,30,000 people died due to this in 14 countries. So because that time there was no tsunami warning system, and most of people not aware about the tsunami word, because now you know, everyone knows what is tsunami, but that time only, that is a Japanese word actually, it's a meaning urban wave. So most of people not aware about the tsunami word itself. So that's why, so that much loss was happened. So after that, got actually one more thing is that time there was no tsunami warning system in the entire Indonesian region. So this center is established after that tsunami, and now we are providing the services to India as well as all countries in the Indonesian region. 25 countries we are serving from this center. So as a part of UNESCO, we are providing services. This is only one center in India. So what we'll do, so we have the database for these 2 regions. Database means it's a numerical simulations. If suppose tsunami generated, earthquake generated here, it's generated tsunami. So what would be the travel time, like 1 hour, 2 hours, 3 hours, 4 hours, and where maximum energy will be focusing, where maximum amplitude will be there. Like that we have the information, like, And suppose tsunami is generated here, we have at least 4 hours time, India. But if it is generated Andaman Nicobar lands, so we have only 2 hours time, east coast. And even here it's generated, we have 2 hours time. So maximum 2 hours to 2.5 hours time will be there to reach that tsunami wave. But in the case of Andaman also part of our country. So then within 20 to 30 minutes that can be reached. So that's why our target is to issue the bulletin within 10 minutes. So within 10 minutes we have to issue that information, tsunami, like where earthquake occurred, that is generating tsunami or not. So then that is first bulletin in 10 minutes. Next 10 minutes we issue if tsunami coming. So each and every location of that example, say Vizag or Chennai or whatever area, when tsunami wave is going to it, what is the wave height? So this information will be available within 20 minutes from the earthquake occurrence. Then everyone knows, okay, tsunami coming. So at 10 o'clock tsunami generated. So then 12:30 it's going to reach to Chennai, and this is the like 3 meters wave height may come. So like that we can inform within 20 minutes time from the earthquake occurrence, and accordingly we can inform to the all the coastal administrators. Then there are 3 categories: warning, alert, watch. So warning means entire area should be evacuated, alert means low-lying areas can be evacuated, and watch means be ready for the next information. Like that we can have the information. Then further we need to confirm. So whatever information got generated, that will be available in the website. Like it's a tsunami website is there. So even this is a real-time website, the information also available. So this type of information is available in real time. Whenever an earthquake got generated, you no need to call also. You can check the website, you can have the okay, that particular earthquake is generating tsunami or not, you can able to identify. So the sea level. No, that map, our real time. For that purpose, we have the two types of sea level sensors. One is called Incois. It's a sensor where deployed at ocean. Here 5 are there, here 2 are there. And apart from that, we have the tide gauge. This triangular in the ports and harbors, we have deployed tide gauge. These both measure the sea level changes. Every minute, what happening in the ocean, it's keep on measuring. So show the animation. Just to discuss. So how this it works means. This first one. Yeah. So how it works means, so this is actual sensor where it's got deployed at ocean bottom, and this is called bottom pressure record. It's measure the ocean pressure. That pressure is converted to the water level height, and this got deployed at 3 to 4 kilometers depth. Actually, ocean will be around 3 to 6 kilometers, and average 4 kilometers depth will be there if we take the Indian Ocean. So in that depth, it can be deployed. And it sends the data information to the surface ball sent to satellite, that data we receive here in the real time. So what happened, it's used to send every 15 minutes interval data if there is no event. But whenever any earthquake occurred, if any tsunami got generated, then it sends every 1 minute data. Due to that, actually due to earthquake, it's got shape and it's went to the tsunami mode, then it sends. And it sends the sound pulses, there is no cable in between. So in the 4 kilometers there is no cable. It sends the sound signal, acoustic signal. The acoustic signal will be converted in the height. It's actually robotic system. So, and that will be converted. And these batteries will come 2 years generally. So every 2 years we have to go there, and we have to recover this. Recover means we go below. So just from the ship, we can give some command. Then there will be a hook. There will be a weight. The hook will be released. This weight will be there only. With the help of this float, it comes out. So we redeployed that system. Each system is around, actually we procured few from the USA. Each system is around 8 crores rupees. So and few are we developing indigenously. So at NIOS, National Institute of Ocean Technology, Chennai. So both systems are there because these are the key sensors. Based on these sensors only we can confirm tsunami generated or not. So that's why these are very important. So apart from that, we have the tide gauges. Tide gauges also keep on measuring what happening in the ocean. So once tsunami got generated, that can be continued up to 10 to 15 hours. Up to that time, we keep on issuing the bulletins with the sea level observation. So what observed at different locations. So then, once tsunami were over, then we issued a tsunami track pass. Show the 3D GS racket. This racket system. How much area is going to inundate? And if suppose tsunami is coming, how much area is going to inundate? It's called 3D GS mapping. So we done the 3D GS mapping for entire Indian coastline. So yeah, that is. And what it's do, it gives the vulnerability wise. How Indian coastline will be vulnerable for next 100 years. It shows. And this is based on the sea level rise, coastal erosion, and different other parameters. And it gives the information that these locations we have the building level information. These cities we have the building level information, and we can overlay the tsunami. If that particular tsunami, how much area is going to come, how much area is going to inundate from the coast to inside, and each building level how much water level may come, and how much flow depth will be there each building, and how much area wise how many buildings will be danger, and how many are in the risk, like high risk, medium risk, and low risk. That information will be provided in the real time. So this is actual data. So we can give this type of inundation area information, and so example it also gives which areas are the like risk wise high. Suppose these areas will be high risk, even though these areas are first it's not low risk but medium because of the low lying areas. So that type of information will be provided to the coastal administrators in the real time. Then they can evacuate the people to the agro. So whenever tsunami coming, that is only one solution. You have to move to the agro. So and ships and vessels have to move into the deep ocean. In the ocean, it won't observe. So generally, tsunami is in the open ocean speed will be equal to jet speed, 800 km per hour. That much fast it can travel in the ocean. But height of the tsunami is very small. It's in few centimeters to meter. But whenever that particular tsunami coming to coast, it is in few tens of meters, and speed will be reduced to say 30 to 40 km per hour. So along the coast areas, damage will be more, and in the open ocean, it's more damage. So that's why wherever the coastline people are there, they have to move to the agro. So that is the only solution. So yeah, that's why awareness is more important. Generally, we used to create awareness trainings. We used to conduct to the coast public, and we used to conduct the mock drills. So every year. So this year also, this next 4th we are conducting for East Coast and 11th for West Coast. So because practice is more important than because cyclones we know every season it comes, but tsunami is not like that. It may come daytime, nighttime, and we have only 2 hours, 3 hours time. Cyclones we have 3 to 4 days time. So that's why very important. So for the tsunami is preparedness. So if you have any questions, please.
This is right. So in this lab, we provide potential fishing zone services. So what is potential fishing zone? You had what is the use of satellites. So in your textbook, it will be mentioned like you can find out where fishes are in the ocean using satellites, right? So from your school, you might be looking at one big antenna it is moving forward and backward, right? So what we do daily, we receive satellite data. So satellite will go on top of our Incois building and we receive the data. So that satellite will dump the data of satellites and we process the data and we tell people based on the satellite data whether there are fishes in the ocean and where can you find more fishes in the ocean. So let us see our temperature on top water, right? And this is chlorophyll. So how do you find based on this chlorophyll in sea surface where the fishes are? So fishes are also animals like us, right? So what animals need? A good environment to live, right? As a conducive environment. We can't live in Antarctica, right? And we can't live in Sahara Desert. So we need some atmosphere, some environment to live, as well as we need some food source. So just like those fishes are also animals, plus food source. So based on the sea surface temperature and chlorophyll, you can identify where are those zones where fishes can live and where are those zones where fish can't live. So they will migrate to the zones where the temperature is conducive for them, where there is a food source. So we can find out those zones where fishes will migrate and we can tell where in that particular zones we can find out. So here you can see these are the zones where we demarcate as this. So here these lines which you are seeing, those are potential fishing zones. Not useful for fishermen, right? So you need to tell fishermen a normal layman language. So if you give a map to them, so he is taking a printout with paper and he can't go search in the ocean, right? So you need to tell them in a useful way. So what we do, we convert this information into a user understandable tables. So in this table, if you see, so from Visakhapatnam to which direction you need to go, and at what distance that fishes will be there. So here you see, from Visakhapatnam, if you go 105 kilometers in north direction or northeast direction, you will find the fish aggregation. So like that, we will convert this scientific data to useful information where fishes will be available in local language. So this is, if you see, this is in Telugu. But your Bengali guy, he is a fisherman in a fishing village, he can't understand English, right? So we'll convert this information into local languages. Next. So if you see, the guy in West Bengal will receive this information in Bengali, and the guy in Odisha will receive this information in Odia. So we convert these tables into local languages and we will distribute it. So daily this thing will happen. So daily we receive the satellite data, we convert that scientific data into fisherman useful information, and we convert it into these tables and we will send. So what is the use of this information? Can you tell anybody, students? So what is the use of this information? We are giving it, right? What is, how fishermen will get benefit from that?
They will get more catch.
Yeah. Yeah.
He can catch more fish.
Yes.
And then?
They can save petrol and petrol.
Yeah.
Petrol or diesel.
Next.
So if you reduce consumption of oil, what happens?
They can earn more.
Any environmental benefits?
So just know whatever you have said. So this is it. So if you use PFZ information,